Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss analysis of single stage common emitter amplifier by using hybrid model. Let's begin. Before starting the topic, we have to understand some basic key points. In the previous video lecture, we are dealing with what be the S parameter, and we draw the equivalent circuit by using S parameter, or we call it as hybrid parameter. These are the two equations, and by using these two equations we draw the equivalent circuit. V1 input voltage, I2 output current. An important nomenclature we have to note down it. This is S parameter and it is written like L1, L2. So, L1 stands for nature of parameter, and L2 stands for transistor configuration. Let us take an example. Input impedance of common emitter. That one is written as, in terms of S parameter, as S. Input impedance, the first letter stands for nature of parameter, I. For common emitter it is E. So, SIE represents the input impedance of common emitter. In this way we noted the S parameter terms. Now, to analyzing that, we have to consider a single stage common emitter amplifier. An NPN transistor, NPN transistor, emitter, base, collector. It has common emitter configuration, base current, collector current, emitter current. Emitter base junction is forward biased, collector emitter junction is reverse biased. We use a source voltage as a source resistance. At output a load resistor is used. The linear circuit of that single stage common emitter amplifier is represented as, this is the black box. Black box we know that is one type of representation in electronics. Without explaining that input components, just understand that the output terminals. We can easily guess what are the properties of that transistor or transistor amplifier. Here input port, input voltage, input current, output port, output voltage and output current, that is the linear circuit. And by using that black box we write two equations for hybrid model S parameter. just relate that equation as we previously derived. Input voltage SI I1 plus SR V2. Here we write for input voltage in that of segment, input voltage is Vi. So, Vi is equal to SI into I1 plus SR V2. SI for common emitter mode of operation, it is SIE. Next I1, here is the input current, here is the input current is IB plus SR, that is SRE, common emitter mode of operation V2, here is the output voltage VO. Next output current IC is equal to SFE IB plus SOE VO. Now, two equations are written by using S parameter, and similarly by using these two equations we can draw the equivalent circuit. The equivalent circuit is drawn here. By using two equations we draw that equivalent circuit. Similar notations used for input current, it is IB, for SI it is written as SIE as common emitter mode of operation. All the notations are just written, all the notations from this segment. We just add a source resistor RS in that of input section, load resistance RL and that of output section. That one is the hybrid equivalent circuit of single stage common emitter amplifier. These are the basics. First we took common emitter amplifier, which one is single stage, its black box representation, and in terms of S parameter we write two equations, and by using that two equations hybrid equivalent circuit is created. Now, by analyzing this hybrid equivalent circuit we can easily evaluate what is input impedance, output impedance, current gain, voltage gain and power gain. Let us discuss one by one. First one, input impedance. Definition of input impedance, that is the ratio of output voltage to input current, voltage by current, input voltage to input current. The impedance is input voltage to input current, input voltage IB, input current, input voltage VI, input current IB, input voltage to input current. As we know from that of expression, VI will be that one, that value of VI is put. So, we obtain, or again same type of notation used, input impedance I as common emitter mode of operation. For that of transistor we use E. In place of VI, the value of VI is put, that one is H IE IB plus H RE VO divided by IB. From equation number 1, the value of VI is put. Next, ZIE is equal to HIE IB. Here output voltage VO is equal to current into resistance. that one is the collector current IC. The current along that of RL negative of IC, the voltage drop across that of RL is equal to minus IC RL. VO output voltage minus IC RL. The value of VO is put minus HRE IC RL divided by IB. Now IB is divided on these two terms, so ZIE is equal to HIE minus HRE RL IC divided by IB. IC divided by IB, output current to that of input current. That one is a technical term which is called the current gain, that we have discussed in upcoming session of that video lecture. IC by IB is equal to AI current gain that notation is used. ZIE is equal to HIE minus HRE RL AIE. The expression for input impedance. Now input impedance we evaluate in terms of S parameters. Next, output impedance. To calculate output impedance, we have to modify as the source signal Vs is to be removed and the load resistance is replaced by a AC voltage source. Therefore, the modified circuit looking like this in order to calculate output impedance. Now, output impedance, output voltage to output current, output voltage VO to that of output current IC. To calculate I of C, as we know the value of I of C from equation number 2, we taken the number of equations, equation number 3, from equation number 2, the value of IC is equal to HFE IB plus HOE VO. We can apply Kirchhoff's voltage law to that of input circuit. Now applying Kirchhoff's voltage law to the input circuit, applying Kirchhoff's voltage law, that one is minus RS IB minus RS IB. Next one is minus IE into B minus IE B. Here minus HRE VO is equal to 0, minus as common from first two terms, IB as common. So, it will be RS plus SIE whole into IB plus HRE VO is equal to 0. First taking minus as common on the top side, minus will be 0, then IB taking common on these first two terms, it will be that much. From this RS plus SIE IB is equal to minus HRE VO, or IB is equal to minus HRE VO divided by RS plus SIE. The value of IB, let me put in that of IC. Let us choose equation number A. Here is the equation number B. So, value of IB is put in equation number A. Value of IB is put in equation A. We get I of C is equal to SOE VO minus HFE HRE VO divided by RS plus HIE, or IC is equal to VO as common. In that of bracket we have SOE minus HFE HRE divided by RS plus HIE, or IC divided by VO is equal to SOE minus HFE HRE divided by RS plus HIE. Now, IC divided by VO, output current to output voltage. Our requirement is output voltage to output current. So, that term with the reciprocal of Z OE is equal to SOE minus HFE HRE divided by RS plus HIE. Taking LCM, RS plus HIE multiplying on that of first term, SOE whole into RS plus HIE minus HFE HRE under simplification the term we obtain as 1 by ZOE. Therefore, the value of ZOE, its reciprocal, that is RS plus HIE divided by expanding that bracket H OE RS plus H OE HIE minus HFE HRE as the expression for output impedance. Equation number 4. Now, output impedance is calculated. Next, current gain. Current gain, we define it ratio of output current to input current. Output current IC, input current IB. Look at that circuit. In that of circuit, the effective impedance can be calculated. We can replace this two resistors to its equivalent resistance as these two are connected parallel with each other. Calculating effective resistance, the effective impedance of 1 by HOE and RL is given by the effective impedance. These two are connected in parallel. The expression 1 by Z is equal to 1 divided by 1 by HOE plus 1 by RL is equal to 1 by Z HOE plus 1 by RL, or 1 by Z is equal to, taking LCM RL HOE RL plus 1, or Z is equal to RL divided by 1 plus HOE RL. Equation small a. It is clear that voltage across RL is equal to voltage across Z. Look at that figure. Voltage across RL is same as voltage across the effective impedance. Here voltage across RL is equal to current into that of resistance, current minus IC into RL. Voltage across Z, HFE IB into Z. Come to that figure. Voltage across RL resistance into current. Here the current will be negative. So minus IC into RL is the voltage across RL. Next, voltage across Z. Voltage across Z, that will be the current H FE IB into Z. H FE IB into Z. Here the value of Z is put, or minus ICRL is equal to HFE IB, value of Z RL divided by 1 plus SOE RL, or minus IC divided by IB is equal to HFE divided by 1 plus SOE into RL, or IC by IB is equal to minus HFE divided by 1 plus SOE into RL, or output current to input current, nothing, that one is the current gain. The expression for current gain A IE, current gain for common emitter mode of configuration, minus H FE 1 plus SOE RL, that E stands for common emitter configuration. That one is the expression for current gain in terms of S parameters. Equation number 5. Next, voltage gain. Voltage gain defined as the ratio of output voltage to input voltage, ratio of output voltage to input voltage, output voltage VO to that of input voltage VI, voltage gain A V of E for common emitter configuration. Now output voltage is equal to minus IC RL. Look at that figure. IC, the direction of IC positive, in that direction it will be negative, minus IC into RL is the VO, output voltage. Therefore, the expression as A VE changes to minus IC RL divided by VI. We can change it, A VE is equal to minus IC by IB. IB is divided, IB is multiplied. There will be no such change in that of equation. Next, A BE is equal to IC by IB, output current to input current, that is the current gain expression, A current gain IE. Next, IB divided by VI, output voltage to output current, sorry, input voltage to input current is the expression for input impedance, as it is the reciprocal, so it is written as 1 divided by expression for input impedance common emitter configuration IE into RL. A VE is equal to minus A IE RL whole divided by ZIE. Let us say equation number small a. Here we can put the value of AIE and AZE. The value of AIE input current gain and ZIE input impedance putted we have AVE is equal to minus HFE RL divided by 1 plus HOE RL into 1 divided by HIE minus HRE RL AIE. Again putting the value of AIE here, we obtain AVE is equal to minus HFE RL whole divided by 1 plus HOE RL whole into HIE minus HRE RL HFE divided by 1 plus HOE RL. The value of AIE put it, or AVE is equal to minus HFE RL divided by HIE HIE 1 plus HOE RL minus HRE RL HFE. As 1 plus HOE RL cancelled out, or AVE is equal to minus HFE RL divided by HIE plus HIE HOE RL minus HRE RL HFE, or AVE is equal to minus HFE RL divided by HIE plus, in these two terms taking RL as common, it will be HIE HOE minus HRE HFE RL. Here we substitute a term in place of HIE HOE minus HRE HFE as del H. That expression is written as AVE is equal to minus HFE RL divided by HIE plus del H to RL. Here HIE IE OE minus H RE FE is equal to del H that one is the expression for voltage gain. I am taking it as equation number 6. Next, power gain. Power gain is defined as the ratio of output power to input power. Power gain for common emitter configuration, output power to input power. What is input power? So, input power P input is equal to input voltage into input current, input voltage into input current. Next, output power PO, output voltage into output current. Now, the value of Pi and PO is put at that expression for power gain. Therefore, A PE is equal to VO IC divided by VI IB, or A PE is equal to VO divided by VI whole into IC divided by IB, or A PE is equal to output voltage to input voltage and the voltage gain A voltage gain VE, output current to input current, that is the expression for current gain A IE. Now, the value of voltage gain and current gain is put here. Therefore, A PE power gain is equal to voltage gain expression, the voltage gain expression that much minus H FE RL divided by H I plus del H RL into A I current gain, the expression for current gain minus H FE divided by 1 plus H OE RL. Now, solving it, we obtain A PE power gain as H FE square RL divided by 1 plus H OE RL whole into H IE plus del H RL. Equation number 7. Expression for power gain. In this way, with the help of this video lecture, we understand the concept of analysis of single stage common emitter amplifier using hybrid model. That one is single stage common emitter amplifier, linear circuit, equation of S parameter, its equivalent circuit. By using that equivalent circuit, we can easily calculate input impedance, for output impedance some modification to that of hybrid circuit, that one is the expression for output impedance. Next, current gain, voltage gain, and finally power gain. All are in terms of hybrid parameters. So, with this useful and informative notes, let me wind up this session. Thank you.